Alright, hello good students. Today I will be showing you guys how to solve a very important question in the physics, thermal expansion per se. Now, the first thing I'm going to do for me is to ensure you don't distract yourself by any means. Settle down and watch this video. Look at the explanation. That is a major thing. Look at the explanation very well. And please, don't skip any part. Just watch the video from the beginning to the end. And in case you have any question, don't forget to drop it in our comment section. Now, after watching the video, don't forget to like the video and also subscribe to our channel if you know you have not done so. Now, what is the question actually all about? The volume of brass increase as a result of heat by 0.45%. Full stop. By how much degree, that is by how much degree was the vessel heated? Now the question is, if the volume of brass increased because it received heat by this percent, then by how much was the vessel heated? How much temperature did it gain? So that's what is the something like the change in temperature? That's what they are trying to ask. How much temperature did you add to this brass so that in order for the brass to increase by such a percentage, 0.45%. Now they said take the alpha for brass to be 1.9 10 to the power minus 5 per Kelvin. Now listen to this. This alpha for brass can also be 2.0 10 to the power minus 5 per Kelvin approximately. Now, what is the meaning of alpha? Symbolically, not as an alphabet, symbolically in the thermal expansion, in case of symbol. I like simplifying my English when I'm teaching so that everybody will be able to follow. Now, in terms of like symbols, if you want to represent something using symbol, now we use alpha to represent what we call the coefficient of linear expansivity. Now we have 4 of them. Remember, we did a class under this expansion a few days back. I hope you have watched that class. Then I told you guys that alpha is for linear expansivity, that is coefficient of linear expansivity. They also have what we call beta for coefficient of superficial or area expansivity. They also have the one we call the gamma, which is for cubic expansivity. So you should know them: alpha, beta, and gamma. Alpha for linear, beta for area or superficial, then the gamma for volume or cubic. So this one is for alpha, that is the linear expansivity of brass. Instead, you should assume it to be this, which is 1.9 times 10 to the power minus 5. Remember, it can also be 2.0 times 10 to the power minus 5 per degree Celsius or per Kelvin. And then per degree Celsius, we put it in per what? Per Kelvin. Now, what about the question? So remember, alpha for brass is this. Now, what do we need gamma for in this question? Why are we writing gamma? Now, remember, the question is the volume, not the length. Now, take note of it is volume that associates with cubic expansivity. Length associates with linear expansivity. So we are dealing with the volume, not length. So we are going to convert this alpha to volume, coefficient of volume, which is gamma. And I told you guys before that gamma is equals to 3 alpha. I hope you have watched that video. We said gamma is equal to what? 3 alpha. Beta is equal to 2 alpha, which is gamma area. This means that volume expansivity, coefficient of volume expansivity is equals to 3 times coefficient of linear expansivity, which is 3 times this stuff we're given. Because we are dealing with the volume, the question, we said the volume of brass, not the length of brass. But if it's length of brass, you can solve with alpha directly. Then we got this for our volume expansivity in per Kelvin or per degree Celsius. Now, what is the meaning of this? What is the meaning of this? Now, remember that percentage is just when you multiply fraction of a whole times 100. Now, change in volume divided by original volume is called fractional increase in volume, or the fraction of this increase. So if you multiply this fraction by 100, you are going to have the percentage increase, which is this I had in this question. This is the percentage increase by this percent. The increase was, that is, this is the percentage increase. Now this percentage increase was gotten by the fraction times 100. I hope we are communicating. So to get back our fraction, because we need this fractional increase in volume, to calculate our change in temperature. So to get back this our fraction, what do we do? To get back this fraction, if you multiply fraction by 100, you're going to get in percentage. To get it back to fraction, if you want to convert percentage to fraction again, which is this change in length over length, this is the fraction. Remember this over this, that is fraction. It's not just any other fraction, it's called fractional increase. Fractional increase in volume. Fractional increase in length is change in length over original length. That's fractional increase in length. So to get this fraction back now, we have to divide this percentage by 100. Remember, to get fraction from percentage, divide the percentage by 100, which is, we are going to have 0.0045. Then remember that cubic expansivity is change in volume divided by original volume times change in temperature or rise in temperature. See, if you have not watched that class, I will advise you to go and watch it. The Best Academy Thermal Expansion. We did linear, area, volume, thermal stress, variation of temperature with density, and modulus of expansion. We did a lot of things there. So you go back, quickly watch that again now after watching this video. So you said volume expansion is equal to change in volume or fractional increase in volume per degree rise in temperature. You can also just see it like that. So this is the fractional increase that we had before, which is 0.0045. Now to make the change temperature is sort of formula, we're going to do cross multiplication. Just multiply this to this place, then move back this back to that other side. So bring this to this side, we're going to have this. Move alpha back to this place, you're going to have this. Gamma, not alpha, you're going to have this. The next, our change in volume over original volume. Remember, that is a fractional increase in volume. We said change in volume over original volume is this, so which is this. Then divided by this gamma, we said gamma is this, which is, so this divided by this, you're going to have 78.95 Kelvin. That is the change in temperature of this body. Thank you. I hope you gain something from this class. Although some people can also do it this way. Some people can also do it this way. They'll just make this change in volume, that's a fractional increase. Then they'll make this original volume unity. You will still get the correct answer. They'll just put 0.0045 here. Then they'll put 1 as the original volume. That is unity. You still get the correct answer. That means you just say this over unity is this, So you are still going to get the answer, which is 1. Just make you can also make the original volume 1. Then make change the volume the fractional increase, which is the percentage divided by what's it called, 100. You also get the answer. You just put 0.0045 1. Okay, 0.0045. Put 1 there. Then put the gamma there. You are still going to get the same answer. So thank you. See you guys now next class. We have a lot of things we are doing here. Please ensure you subscribe to our channel, like this video. It will help us a lot. Thank you.